So in this video, we're going to look at how to solve equations of the form sine of bx minus c, right? So let's look at the equation sine of x equals root 2 over 2. Now, just know that this is going to have multiple solutions because remember sine is a periodic function. So every 2 pi, if you add 2 pi to the x, then I'm going to get the same value, right? So we want to figure out what are all the solutions or all the points x such that sine of x is equal to root 2 over 2. So the first thing I'm going to do here is I'm going to solve an equation of the form. So let's say step 1. Okay, I'm going to solve an equation which is sine. So solve sine of x prime equals root 2 over 2. Okay, and what is x prime? Well, x prime is the reference angle. And if you remember, reference angles are always positive acute angles, so they're always in the first quadrant, right? So sine of x prime equals root 2 over 2. So which acute positive angle can you think of such that sine of that angle is going to be root 2 over 2? And we know that from our table, and that's going to be pi over 4, right? So we know that sine of pi over 4 is going to be root 2 over 2. So we know that x prime is going to be pi over 4. Okay. Now, we know that sine has a period of 2 pi, right? And that sine is positive in quadrant 1 and quadrant 2. Okay, so if you look in the interval, so in the interval from 0 to 2 pi, right? If you look at this one rotation, right? So here's, if I look at this one rotation, okay, the only places that I can have sine x equals root 2 over 2 are in the first quadrant and in the second quadrant, okay? And so that's going to be x would either be equal to your reference angle in this case, which is pi over 4, or x is going to be in the second quadrant, which is pi minus pi over 4, or that is 3 pi over 4. Okay, so in one revolution from 0 to 2 pi, sine can only take the values of pi over 4 or 3 pi over 4. Okay, now that leads me to my final step, and that is finding all solutions. Okay, so think about it now. I have this value, which is pi over 4, and this value here, which is 3 pi over 4, right? If I start the point here, if I add 2 pi, I get back here. If I add 4 pi, I get back here. Same way with this one. If I add 2 pi, I get back here. 4 pi, I'm going to get back here, and so on. Okay, so all my solutions, basically all I need to do is add 2 pi, because if I add 2 pi, I end up at the same terminal point, right? And so all my solutions are going to be x equals pi over 4 plus 2n pi, right? Because I could add 2 pi, I could add 4 pi, 6 pi, 8 pi, so on and so forth. Or I have x equals 3 pi over 4 plus 2n pi, okay, where n is an integer. Right? N could be a positive integer, n could be a negative integer, n could be 0. So these are all my solutions to the equation sine of x equals root 2 over 2. Okay, so just a recap, first thing you will do is you'll find a reference angle. Okay, and remember the reference angle is always in the first quadrant, so this value will always come out to be positive. Once you found your reference angle, then think about your unit circle, okay? And then think about where your function is positive. In this case, I have a sine function, so sine is positive in quadrant 1 and quadrant 3. Oh, sorry, quadrant 1 and quadrant 2, okay? So it's going to be pi over 4, or if you remember from when we did reference angles, that if the angle in pi in the second quadrant with a reference angle of pi over 4 is going to be pi minus pi over 4, which is 3 pi over 4, okay? And that is only in one revolution, right? So if I go from here all the way back, then that gives me these two solutions, okay? So all possible solutions, since it's a periodic function of 2 pi, all I do is I add multiples of 2 pi to my solutions here, and that gives me a list of all possible solutions that can give me an answer of root 2 over 2.